Okay, today is the last day of trigonometric functions of any angle. Tomorrow, that's Thursday, we'll have a review, and Friday, a test on this stuff. It's predominantly on section 5.3, although section 5.4 is the same type of stuff. I won't give you any homework out of that, but it's section 5.3. Okay, the first topic of the day is what are called quadrantal angles. And these are angles that terminate on an axis. There was one in the homework, and I failed to mention that. That was problem number 72, so we'll go over that one. There wasn't an example like it in the odd problems, and it was my mistake for not talking about that. All right, quadrantal angles, they terminate on an axis. All right, for example, let's say that we have theta equal to 90 degrees. All right, well, that is this angle right here. It terminates. Its initial side is the positive x-axis. Of course, the terminal side is right there. Now, these angles have no reference angle. Now, the reason they have no reference angle is the reference angle is defined as a positive acute angle from the horizontal axis to the terminal side. Well, 90 degrees is not an acute angle. 90 degrees is a right angle. So any angle that terminates on an axis has no reference angle. An acute angle is not 90, an acute angle is not 0. Okay, so these have no reference angles. Now, what are the values of the sine, cosine, and the other functions on these quadrantal angles? Well, we find them the same way that we find the other things. The sine of theta is found directly on the unit circle, as is the cosine. Let's write these both down at the same time. Okay, let's look at 90 degrees, or pi over 2. Okay, the sine is this value, the y-coordinate, the cosine is that value, the x-coordinate. So the sine is 1, the cosine is 0. Okay, now the tangent is the y divided by the x. 1 divided by 0. Well, 1 divided by 0 is undefined. Tan of theta is undefined. There is no tangent at that value. Okay. Well, let's go to the grapher. All right. And I'm going to check my mode first thing. And I'm in degree mode, so that's good. Okay, so I'm going to take the sine of 90. Tan, or pardon me, cosine of 90, and tan of 90. Undefined. When it says arrow domain, that means it's undefined. Okay, now the others, cosecant of theta is the reciprocal of 1. Well, the reciprocal of 1 is 1. Secant, the reciprocal of 0, well, 1 divided by 0 is undefined. There is no reciprocal. Okay, the tangent, the cotangent now, that's a little tricky. If we go to the unit circle, if the tangent is y over x, the cotangent is x over y. 0 divided by 1 is 0. Okay. Okay, now we can do this by grapher. Okay, to define the cosecant of an angle, first thing we do is define the sine of that angle. And then once we're done, we use the reciprocal button, find its reciprocal. Cosine. We find the cosine, then we use the reciprocal button. It says undefined. Good. All right, tan of 90, undefined. Now, if I try to take the reciprocal, it won't allow me because this is already in error mode. One thing you're going to have to remember about the cotangent function, if the tangent comes up as undefined, the cotangent is not undefined. You have to go to the unit circle and look at it. Okay, now it only is a very special case, and it only comes up when the one of these angles terminates on the vertical axis. You cannot take the cotangent and check cotangent by grapher on any angle that terminates on the vertical axis. It just can't be done. All right, so let's look at some of your homework. Okay, problem number, or the examples. It asks for the cosine of pi. All right, well, let's draw that in standard position. And by the way, a couple people handed in their homework and they did not draw the angles in standard position. I'm asking you to draw these angles in standard position. Okay, this is a radian problem. All right, here is pi. Okay, all we have to do is go to the unit circle to check this out. There's pi. Well, my hole punches. Punch that out. That's the point -1, 0 on the unit circle. So the cosine of pi is -1. All right, well, let's check by grapher. First thing we do, make sure we're in the right mode. Cosine pi -1. Check by grapher. Problem number 11. Secant of pi. Well, secant is reciprocal of cosine. Okay, well, it's the same angle in standard position. All right, now that is the reciprocal of -1. Well, let's do that by grapher, just to make sure. You should have known that. The reciprocal of -1 is -1. The reciprocal of 1 is 1. The reciprocal of -1 is -1. Okay, number 13. Tan of 3 pi over 2. Okay. All right. Where's 3 pi over 2? Well, we can look at the unit circle, and we know that one. That one is down here. So here is tan. Or that's 3 pi over 2 right there. Okay. The tan is the y over the x. It's -1 divided by 0. Now that is an undefined. All right, we're going to check by grapher. We're in radian mode. That's the last mode we were in. I'm going to take tan 3 pi divided by 2. Undefined. Okay. And number 15, cotangent. Oops. Right in the spot I'm supposed to be in. Cotangent of pi over 2. That is the same angle that we did right here. Pi over 2 and 90 degrees are the same, so cotangent is 0. We'll write this out. Here's the angle. Theta is equal to pi over 2. Now, cotangent, keep in mind the tangent is y over x, so cotangent has to be x over y. Okay, 0 over 1, which is 0. And remember, there is no way of checking that by grapher. It just can't be done. Okay, now that's the first part of your homework tonight. You have those problems, and they're pretty easy. There's only 3 of them, and you don't have to do a lot of work, but I do want you to draw them in standard position. Okay, the second part of your homework are problems from 23 to 33. We're going to do 3 of them. All right, start with number 23. Now, 23 says, given this information, cosine theta is equal to -3/5, and theta is in quadrant 3. Find the exact value of the remaining 6, the other 5 trigonometric ratios. Okay, well, first thing we do is draw an angle in standard position. Now, quadrant 3 is this region right here. If the cosine is -3 over 5, the cosine is negative in quadrant 3. We know that because cosine is not positive in this quadrant. And we also know SOHCAHTOA. Put that up there. All right, so cosine is adjacent over hypotenuse. So what we need is a triangle down here where the adjacent side is 3 and the hypotenuse is 5. Okay, so we can draw that. 3, 5. Now, you may know that that's a 4. If you don't, use the Pythagorean theorem. All right, here is theta. Now this angle right here, and I'll put it in red, is theta prime, the reference angle. And we're going to need that reference angle to check by grapher. All right, so I'm going to write cosine theta first. And right next to that, I'm going to write secant theta because it is a reciprocal and it has to be negative 5/3. That's easy to come by. All right, sine of theta. And at this point, I should put this point here. That's a 3, that's a 4. Those are negative values. This is the point here has negative coordinates in both because it's quadrant 3. These are triangle sides. They're listed as positive values. Those are negative values because they're part of a coordinate in a third quadrant set of coordinates. Okay, by definition, the sine is the y-coordinate divided by the hypotenuse. It's also opposite over hypotenuse and negative in the third quadrant. So cosecant theta must be negative 5/4, the reciprocal. Tan theta, tangent remember is positive in this quadrant, 4/3, opposite over adjacent, cotangent theta, 3/4. All right, here's how we check by grapher. Let's do this in degrees because it makes a little bit more sense. All right, so I'm going to go to degrees because you can visualize maybe a little bit better. All right, I'm going to find theta prime is, and I'm going to use inverse cosine, but I'm not going to use negative 3/5. I'm going to use positive 3/5. Inverse cosine of positive 3/5. I could also find theta prime by the inverse sine of positive 4/5 or the inverse tan, these are inverses, of positive 4/3. Any one of them is going to get me the theta prime that I'm looking for, and here I'll show you. Inverse cosine of 3/5. 53-degree angle. Seems reasonable. Inverse sine, 4/5. Inverse tan, 4/3. Okay, every one of those angles is the same angle, and you get them by always using positive ratios to find reference angles. Always. Never use the negatives because that's going to give you the wrong number. Use the positive ratios to find reference angles. All right, so we get that number on our screen. To find theta, that's 180 degrees plus theta prime. That's in the third quadrant. You have to look at the picture to determine this. Theta is the 180 plus that. There is no formula to find theta under these circumstances. You have to look at the diagram and use a little logic. Okay, so we're going to add 180. That is theta, and I will store theta in the grapher. Okay, now I'm going to check this by grapher. Cosine theta, negative 0.6, which is negative 3/5. Sine theta, negative 0.8. Perfect. Tan theta, positive 4/3. All right, everything checks out. Now, when you do your homework, you don't have to write all this stuff down. You have to do it. This is what the answers to the question are. And when we take the quiz, these are the answers I'll be looking for. But there's no reason to get any of it wrong because you can check every answer by grapher. Okay, next problem is number 27. Now this one says cosine theta is equal to positive 8 divided by 17. And it says that 270 degrees is less than theta, which is less than 360 degrees. Okay, again, we will draw a picture 270 to 360. That's quadrant 4 down in this area. Okay, so I'm going to draw my... Okay, so cosine being adjacent over hypotenuse. So we're looking for a triangle that has an 8 as an adjacent and a 17 is the hypotenuse. You know, maybe something like this. Now, we don't know that one. All right, well, we have, and you probably don't know this. It's 15. I know that, but you might have to find it. Okay, that's a 17 there. Okay. All right, so I would write the Pythagorean theorem. 8 squared plus y squared is equal to 17 squared. That's 64 plus y squared is equal to 289. Y squared is equal to 225, so y must be 15. Okay, so you have to figure that out. Maybe you know it. Okay, I'm going to write this point in here. That's a positive distance. That's an x. This is a positive distance, but the y-coordinate is down here, so that's a negative 15. All right, here is theta. That's theta prime. Okay. All right, now that's a complete diagram. Every time I say draw an angle in standard position, a complete diagram is triangle, theta, theta prime, coordinates and sides of the triangle clearly labeled. All right, cosine was given is positive 8/17. That means that the secant of theta is 17/8. Sine theta, negative 15 over 17, sine being negative in that quadrant. Cosecant theta, negative 17 over 15. Remember, if this is negative, that's negative. The subtraction is either negative or it's positive. In this case, these... And another thing I should mention, reciprocals are always... They always have the same sign, S-I-G-N, as the fraction that they're reciprocal of. So if this is negative, that's negative. Okay, tan theta. Now tan is negative in this quadrant because the only cosine positive. So opposite over adjacent, so it is negative 15 over 8. Cotangent must be negative 8 over 15. Okay, let's check by grapher. First thing we do, find a reference angle. Well, we take either the inverse cosine of 8/17, the inverse sine of positive 15/17, or the inverse tan of positive 15 over 8. Any one of them. I'll just use the cosine. Inverse cosine of positive 8/17. Remember, always positive. Okay, that is the reference angle. I'll even write this down. Theta prime inverse cosine of 8/17. Okay, so theta itself is 360 minus theta prime. Now I know that because this is all the way around 360. I have to subtract that amount off to get to this amount. It should be a number between 270 and 360. It says right there. Okay, so I take 360 minus the last answer that was on the calculator. 298 degrees approximately. Okay, we will store that in theta. Now I'm going to check by grapher. Cosine theta, math enter. Perfect. Sine theta, negative, of course, math enter. Negative 15/17. Tan theta, math enter. Okay, worked out very nicely. Okay, last problem. Number 29. The given information is tangent theta is equal to negative 2/3. And sine of theta is greater than 0. All right, so we're going to have to draw an angle in standard position. All right, well, let's take a look here. Tangent is negative 2/3. Okay, well, that can't be down here because tangent's positive there. It says sine is greater than 0, that puts it up here, and tangent's negative there. So this has got to be a second quadrant angle. Okay. Now tangent, the ratio is opposite to adjacent. So I'm going to draw a triangle over here where this side is a 2 and that's a 3. All right. Now this point is negative 3, 2. All right. I do not know that hypotenuse. Well, 2 squared plus 3 squared is equal to c squared. 4 plus 9. C squared is equal to 13. So c is the square root of 13. Okay. Now, it's okay to have a square root. It's not a perfect square. All right, so we're just going to have to deal with that. Okay, so tangent theta, that was given to us first. So we might as well just go ahead and write that. Cotangent theta, then, is that reciprocal, negative 3 over 2. Sine of theta, we'll do that one first. Okay, sine is opposite over hypotenuse, and sine is positive in this quadrant. So the opposite is 2 over the square root of 13. Now we could rationalize that, but I'm not going to bother. Cosecant, then, of theta is the square root of 13 over 2. Cosine of theta, adjacent over hypotenuse, but cosine is negative in this quadrant, so that would be negative 3 divided by the square root of 13. Secant theta is then the reciprocal here, negative square root of 13 over 3. All right, let's find the reference angle. Now, let's use inverse tan, but not of negative 2/3, of positive 2/3. You never use negative reference. Okay, I'm going to slide this up so we can get the calculator in screen. Okay, so I will take inverse tan of positive 2/3. Okay, there's the reference angle. 33.7 degrees. Okay, well, before I do that, I am remiss. There's theta. Here's theta prime. Now that's a full diagram now. I do make mistakes. Okay. All right, so how do I get theta this time? Well, this is 180 degrees. I got to take that theta prime away from 180. Okay, so I do 180 minus the last answer on the screen. There's theta. Okay, so theta, I'm going to write this down, 180 minus theta prime. Theta is approximately 146.4 degrees. We're going to store that. Okay, now I'm going to check my work. Tan theta okay, you should recognize that. 2/3. Okay, that's good. All right, sine theta. First thing we'd see is it's positive. That's good because we were expecting a positive value because we knew that. All right, now if you don't know off the top of your head what 2 divided by the square root of 13 is, you check this by 2 divided by the square root of 13. Okay, check. Cosine theta. All right, negative, that's good. Now we'll check 3 divided by the square root of 13. Now, I don't have to type a negative in here because I already knew that since we got the negative that came out of the calculator, that part of it was right. We're just checking to see if this decimal is the same decimal, and it is. Okay, now these problems are not easy for beginning trigonometry students. But every one of them can be checked by Grapher. I will post these notes, and you can look at them as you watch the video. Those of you who do watch the videos, I have to say, I think we're about, I checked the views on this, we're about 50%. I mean, I don't know how the rest of you are doing this work if you don't watch it. Maybe you're reading the book. That would be good. But you should watch the video. So, I mean, anyhow, I spend a lot of time on these videos. All right, here's your homework. I'll put it over here because I'm out of room. All right, or assignment, no homework. All All right, we're still in section 5.3, last day here. You've got numbers 10, 12, 14, 16. Okay, those are the quadrantal angles. And then you have number 24, number 30, or pardon me, number 28 and number 30, yes, I'm sorry. 24, 28, and 30. All right, there probably will not be a video tomorrow. I'm going to post an assignment, and I'll put a review up there. And then the quiz will be Friday that you'll have to turn in. I don't know if you're going to have to turn this homework assignment in. Maybe you will, maybe you won't. I'll tell you tomorrow. All right, goodbye.